Welcome to RTXRoom. In this video, we present the project consortium, the RTXRoom solution, and the key results from its large-scale pilot execution in an industrial training context. The motivation behind RTXRoom arises from a clear need within the manufacturing sector, particularly in the aluminum industry, for flexible, scalable, and effective training solutions. Traditional training often involves high operational and travel costs, limited access to expert instructors, safety risks during hands-on procedures, and challenges in maintaining learner engagement. From a pedagogical perspective, existing methods also struggle to support personalized instruction, collaborative learning, and real-time performance feedback. RTXRoom addresses these challenges by introducing an XR-based training solution that supports immersive instruction, personalization, and remote and collaborative learning. RTXRoom is an immersive extended reality training solution that builds upon D-Cube's existing HoloLens-based system and integrates XR2Learn's personalization enablers. Designed specifically for industrial use cases, it combines gesture-based interaction, expert-guided instruction, and multi-user collaboration. The system adapts in real time, adjusting the training pace and level of support based on user performance, body tracking, and emotional state, delivering a personalized learning experience for each participant. D-Cube and the Architectural Aluminum Academy work closely together, ensuring that the developed solution combines technical excellence with strong real-world relevance and direct applicability in professional training environments. D-Cube is a spin-off company of the Center for Research and Technology Hellas. Its vision is to transform world-leading research into business value. In recent years, D-Cube has identified a strong demand for the modernization of industrial training through immersive technologies and has invested in developing advanced XR applications that combine technical innovation with deep industrial insight. The Architectural Aluminum Academy is the innovation, skills development, and competence center for architectural aluminum systems, with training facilities in Athens and Thessaloniki. The Academy plays a key role in upskilling and certifying professionals in the aluminum frame and construction sector, offering specialized programs for technicians, self-employed professionals, and companies. Next, we present the key features of D-Cube's XR solution, which is the narrative editor, the RTXR, and the streaming editor. On top of these exists the RTXRoom, leveraging XR2Learn's personalization enablers. The narrative editor is a no-code desktop authoring tool that enables trainers and domain experts to create XR-ready aluminum assembly scenarios without any programming skills. Through an intuitive visual interface, users can define step-by-step assembly procedures, animate parts and tools, and enrich each step with supporting media such as images, videos, audio, or documents. This allows training content to be authored directly by experts, preserving their know-how and transforming it into structured, reusable XR training experiences that can be seamlessly deployed across immersive learning platforms. RTXR is an augmented reality training application that delivers step-by-step guidance through interactive 3D manuals directly within the learner's physical workspace. Using spatial instructions, contextual user interface elements, and intuitive hand-based interaction, RTXR allows users to navigate assembly procedures naturally, without breaking focus from the task at hand. Learners can move between steps, inspect individual components, and follow animated 3D instructions. At the same time, original fabrication manuals in PDF format are fully integrated into the experience, allowing users to consult official documentation whenever additional reference or verification is needed. This combination of immersive guidance and standard documentation supports both learning and compliance with established industrial procedures. In this video, two users collaboratively perform the same assembly task using RTXR. Both participants follow a synchronized instruction flow, ensuring a shared understanding of the current step and overall progress. Each assembly step is presented visually, showing how parts should be positioned, oriented, and connected. These animations act as a clear reference, reducing ambiguity and helping learners understand complex procedures more effectively than traditional paper-based instructions. As the animated 3D instructions are displayed, users perform the corresponding actions on the physical workbench, translating virtual guidance into real-world execution. Through this approach, RTXR supports hands-on learning, collaboration, and consistency in industrial training, enabling learners to acquire practical skills safely, efficiently, and with reduced dependency on constant on-site supervision. The streaming editor is D-Cube's remote assistance application, designed to support trainers and experts during XR training sessions. It allows supervisors to view the learner's field of view in real time, exactly as seen through the XR headset. Through this live stream, experts can remotely monitor progress, provide guidance, and intervene when needed during the execution of assembly tasks. This approach enables effective supervision and expert support without requiring physical presence on site, helping reduce costs while maintaining training quality and safety. RTXRoom was validated through large-scale pilot sessions conducted in 2 phases at the Architectural Aluminum Academy. The pilot involved real trainees, trainers, and realistic industrial aluminum assembly scenarios, ensuring that the evaluation reflected authentic training conditions. Each training session began with a familiarization phase, where participants were introduced to the XR environment before entering the full training scenarios. During this phase, users practiced basic interactions such as air taps, scrolling, and object manipulation, allowing them to build confidence, comfort, and precision when working with the XR system. 2 main training scenarios were implemented during the pilot: an individual aluminum frame assembly guided step-by-step in XR, and a collaborative multi-user assembly scenario. The collaborative scenario enabled multiple users to work together within the same XR-guided workflow, supporting coordination, shared understanding, and team-based learning. While wearing the HoloLens, participants interacted with the XR2Learn personalization toolchain directly in front of the assembly table. The system provided adaptive, real-time guidance tailored to each learner's needs while they performed the physical assembly task. Beyond the pilot execution, RTXRoom also contributed directly to the XR2Learn platform ecosystem. As part of this work, we uploaded a set of 3D training assets and tools, making them available through the XR2Learn platform for reuse and future experimentation. In parallel, we created and published an open online RTXRoom familiarization course designed to support onboarding and independent adoption of the platform. The course consists of 2 structured lessons. The first, Setup and Navigation, introduces users to the RTXRoom environment, covering system setup, navigation, and basic interaction. The second lesson, Run a Training Session, demonstrates how to conduct a complete XR training session, including scenario execution, collaboration, and available training features. Finally, the course concludes with a comprehensive questionnaire designed to gather structured feedback and usage data, supporting continuous improvement and future research within XR2Learn. Pilot results demonstrate high user satisfaction, a significant reduction in training errors, and strong acceptance by both trainees and trainers. The immersive, guided, and personalized approach improved understanding and confidence during assembly tasks. The feedback, which comes directly from the Academy's trainers and management team, highlights that RTXRoom had a tangible impact on their daily training workflow, improving clarity, reducing errors, and supporting more consistent and confident instruction. This feedback confirms that RTXRoom is not just a technological solution, but a practical training tool that fits naturally into real industrial education environments. Based on the pilot results, RTXRoom has reached Technology Readiness Level 8 and Manufacturing Readiness Level 5, confirming its readiness for real-world deployment and scalability across industrial training sectors. This figure summarizes the overall impact pathway of RTXRoom following the pilot execution. Starting from real industrial training programs, the pilot demonstrated measurable benefits, such as fewer training errors and increased user confidence. As the system scales, these improvements translate into higher user satisfaction and a robust, scalable training solution that can be integrated into different learning formats. Building on these validated results, RTXRoom is positioned for commercial exploitation and long-term adoption across industrial sectors with similar training complexity. Thank you for watching. For more information, please visit the project website.